Okay, in this very short video, I will demonstrate how to use Tracker to extract information from a video. Uh, let's go. So I'm using a Mac, so I'm searching for Tracker on my uh, Mac. So it starts up. And so I'm giving you a sample video. It's called Tutorial Activity Prep Sample Video. All you need to do is just drag and drop it into the video panel. So in this particular video, we have a mesh that is hung on a spring, and very conveniently, we have got a half-meter rule that is prominently displayed in the video. So we want to extract information about the position and velocity and acceleration of this mass with time, and we have actually done a clever thing by putting a red sticker on the mass. This is because what Tracker will do is to try and do some pattern recognition and basically identify the position of a group of pixels, in this case the red sticker, in every frame. So it helps that your uh, uh, tra- tracking group of pixels is prominent. Okay, so it actually helps that the background is uniform. Here we have a very confusing background, but as you will see, it doesn't affect our tracking for this case. In general, it's a good idea to have a uniform color background. So what I'm going to do right now, which I have done, is I click on this, I create a coordinate axis. So I'm just going to put the coordinate axis maybe somewhere here, maybe this way. If you like, if you can drag on this little tick here, you will be able to rotate the axis. For our purposes, I want to have it vertical. Okay, so once the axis is there, you will need a calibration length. Okay, so click on create, calibration tool, calibration stick, and it says here shift click to mark. So I'm going to mark one point on this half meter rule and 1 point on the end. So the resolution isn't very good, so I do not know actually what is the marking here, but nevertheless I will try. Okay, shift control shift click, that's one end, and here shift click. Okay, so they have a box here where you can put in the length that you just marked out. So this should be around 0.5 meters, maybe a bit less, so I'm just going to guess 0.45. So obviously if you want an accurate tracking, you should not be guessing, because otherwise your data will be inaccurate. But for practice, let's just guess. Okay, so once the axis and the calibration stick is done, you will want to uh, be able to track this. So you create a point mass. Okay, so this thing comes out, and when it's by default called mass A, so you click on mass A, you can auto track. Okay, so click on auto tracker, and what will appear, let me just shift these around. Okay, what will appear is this pop-up. The instructions are very clear. It says shift control click the video feature of interest. Okay, so shift control click, I want to click on this. So shift control, right, and it gets me this circle. I'll click right here. Okay, so after a while it's got a template, right? This group of pixels is what is going to track. Okay, so there are some options. It will look ahead, um, uh, the evolution rate, and so on. You can play around with it. Okay, so what you want to do next is just to search. So let me just move the things so that later you will see better. Okay, let's go. So what is displaying now, it seems kind of random. It's x position against time. So it's tracking the x position, but this mass is moving vertically. What we really want to see is the y position, let's say. And you can see that it does a pretty good job. So it's gone to its end frame. So you can actually, as you saw, not just display y, but a whole host of other properties. So let me, because I know that the acceleration is related to the position. So let me just display acceleration in the y direction with the y position. Okay, so you can see a lot of data points and they are all linked by lines. It looks very confusing. So let's just analyze it a bit more. So how to analyze would be to do a right click, go to analyze. Okay, so these data points are being displayed. Let's get rid of the lines. Okay, so these are the points. So it's quite clear that the they are related linearly with a negative slope, but it's not very clear that our choice of the uh, axis position was correct, because there is an offset from 0. Okay, theoretically they are supposed to pass through 0. Okay, but nevertheless we can still analyze it. So go to analyze. There are a few things to do here, so let's do curve fitting, and the default is a straight line. Okay, so as you can see, the best fit straight line is already shown to you. So there is a negative slope indeed. A is your negative slope, is this value. E just stands for times 10 to the power of. Okay, so B is the offset that we were talking about. If you had a different choice of axis, it would be a different value of B. Okay, so let's close this. If this is all you need, then you have what you need. You can even export the data to Excel and so on. Okay, the videos on Tracker in YouTube will be able to tell you that, or you can just play around with it. I want to show you other ways to do the curve fitting. So let me just close this. We saw y against time and it looks very so-called regular. Okay, so let's right click on this and analyze this one. Okay, so I don't want a line to be fitted. Okay, I want a sinusoid, but it's not doing a good job doing this auto fitting. Okay, and we know that there was some offset because of our choice of axis, so we probably need to do a bit more fitting in terms of including an offset in here. So this you can double click, oh no, right click. Okay, so I'm going to add a plus D for offset, and it says now it's probably an invalid expression. That's because in my parameters I do not have D, so I'm just going to add D to the parameter. It's by default just parameter, so well, description offset. Okay, double click, change this to D. Okay, so close, and now I have a new fit equation. I don't think AutoFit will do a good job, so I might have to guess. The A is your amplitude, so that's about 4 times 10 to the power of minus 2, certainly not minus 12. Okay. B is the frequency, so it looks like it's maybe 1 cycle every second, or maybe more than that. So let's try. Okay, maybe something like that. C is your offset in terms of the time. So maybe just a guess. All right, and then D is the offset in terms of the position. Okay, so this looks quite manual. There are better software for doing curve fitting. All right, things in Python, MATLAB, these do it much better. Okay, so the other thing I want to show you under Analyze is the Fourier spectrum. So what a Fourier spectrum does is it looks at the data and is able to give you the frequency of any cycles in this time series, okay, the data against time. So let's try that. And you can see that there is one peak frequency at about 1 plus hertz, okay, which was what we thought the frequency should be like, right? Okay, so I hope you enjoy using Tracker. Just play around with it. We will have an activity on Tracker and rolling motion during our tutorial.